So what we have here is a very simple input button. As you can see, just standard press button, monetary button, meaning that it will register the status being pressed as long as you hold it down. The moment you release it, the microcontroller will release that the button is free again. So to demonstrate this, we're going to plug our button into D1, for example. And on the scripting side, we are going to open up the registers as well. So the registers page, whenever you run a script, the registers page will be able to tell you what input's being received as well as the output that's going to be written in the next program cycle. So to demonstrate what that means is, let's first define our button, and that's connected to pin D1. So we've got a button switch, and we're not going to specify a script, not now. Just want to show you what is meant. Oh, button, let's call it button instead. So save, compile, and run. And so although nothing is happening now, you'll see that on the register side now, whereas it was empty just before, now we have pin D1 that's registered here, and it reads register 1 as 0. Now 0 is false and 1 equals true in this case, and that's simply the status of the button. So if we pick this up and we press the button, you'll see that this page updates every 2.5 seconds, so please just be patient if it doesn't update immediately. But within 2.5 seconds you'll see that it changes from 0 to 1, and also if you release the button it will go back to 0 again. Now of course this is just the page that takes 2.5 seconds to update, whereas the script in the background, it runs instantaneously. So if you use this button as input into another device, then the moment you press the script, then that other device will be able to, read it as input. So to demonstrate that, we're bringing back our old LED component, and we're just going to plug that in on this side onto pins D5 and D6. We're going to push them over there so that we can still have the button here. And while I'm holding on to that, going back to our script, I stop it first. And now, like before, we need to define D5 and D6 as two output LEDs. Now, instead of declaring a timer, we're simply going to say that if D1 is pressed, then we want D5 to be on and D6 should be off. So the green LED will be on and the red LED will be off. And now we can also use the else statement. We can say if the button is not pressed, then D5 should be off, whereas D6 should be on. And now to test our script, we're going to save over button, compile, select run script. What's going to happen is the red LED will start up initially, and it will remain that way until we press the button, in which will go over to green. The moment we release, back to red. If you go over to the scripting page again, you'll see that we've got the input pin as D1, and D5 and 6 obviously are the two LEDs. Now you can see that they're all in 0 state. Whereas if I press the button, that one reads 1. Just refresh. And if I release it, it goes back to 0. This is just to show you the delay in HTML getting the instruction from the microcontroller versus the responsiveness in terms of the script running in the background. And that's it for the simple input component, which is the button.